Welcome to another video for General Science. In this video, we're going to be discussing momentum. When you think of momentum, think of mass in motion. As long as the object has mass and it has a velocity, then you're going to have momentum. Here's my formula for momentum. I have lowercase p, which stands for momentum, my lowercase m for mass, and v also for velocity. Okay? So here you have a short video of beast mode, Marshawn Lynch running the ball. He has momentum. Momentum is a vector, and he also has a velocity. Momentum's vector always goes in the same direction as the velocity vector. Okay? So my formula for momentum is our velocity times the mass of the running back. And you'll notice that nobody is able to stop him. That means you have to either apply an equal amount or greater amount of momentum in the opposite direction of the velocity vector for the running back. As you can see here, the opposing players, the Cardinals, they're not applying enough of their own momentum to stop him. Thus, at best, they're barely slowing him down. Okay? So let's take a look at an actual problem here. So if a running back has a mass of 60 kilograms, and he has an eastward velocity of 7 meters per second, what is his momentum? So we're going to apply our formula. We have a mass of 60 kilograms, a velocity of 6, and that computes to 360 kilograms times mass per second. Now, as you can see here, you might notice that this running back's mass is quite a bit bigger. So the question that we want to discuss in this particular part of the video is what happens to the momentum of an object or a person when the mass increases. Okay, so what if my running back doubled his mass in the next year? What would happen to his momentum? Okay, as you can see here, he's pretty tough to bring down because of the momentum that he's able to harness by increasing his velocity and direction towards the end zone there. Okay. So let's take a look at the momentum formula to find out what happens when you affect mass. Now, the thing with mass and velocity for momentum, there's a direct variation, there's a direct relationship between these terms. Unlike the previous physics problems that we've done, there was an indirect relationship, an inverse relationship, where if one increased, then the other would decrease, or if it decreased, then the other would increase. In this case, because of the direct variation, if I increase either my mass or my velocity, then my momentum will naturally increase. And if you think about it, it kind of makes intuitive sense, because if my object is getting bigger, and assuming the velocity remains the same, if my object is getting bigger, then it's creating more inertia. It's got more momentum going in a direction, which is going to require more force to slow it down or bring it to a complete stop. Okay, so if mass increases or velocity increases, then momentum will increase as well. Okay, there's a direct variation between these terms. If my mass doubles, then that means my momentum doubles. If my mass remains the same and my velocity doubles, then my momentum still doubles. Now, what happens if my mass doubles and my velocity doubles? Well, if they both double, then my momentum now raises up by 4 terms. So that means it quadruples. Okay, so again, however you affect mass or velocity, it's going to directly affect my momentum in the exact same way. That does it for momentum video. Thanks for listening, and good luck in your study.